So 2.6, properties of real numbers. Like I just told you, we cover this section first. I go out of order because I think this is the easiest section in this chapter. We're not going to do all proofs all the time, but we're going to do these easy ones, okay? So even if you think you don't know these properties, you actually kind of do. The first one here is the addition property of equality. So if I had x minus 4 equals 2, if I had x minus 4 equals 2, you don't have to write this down, okay? I'm just giving you an example. What would I do to both sides to get x alone? Add 4 to both sides. Does everybody get that? You've known that for forever. So because I added the same thing to both sides, it's called the addition property of equality. So this is an example of when you would do that. Does that make sense to you guys? Okay? So same thing. We have subtraction property of equality. If a equals b, then a minus c equals b minus c. So if I had this time, x plus 4 equals 2, how would I get x alone? Subtract the 4 from both sides, right? So subtraction property of equality. Okay? Multiplication, same thing. You multiply by the same thing on both sides. Division, divide by the same thing on both sides. Okay? Reflexive property of equality. If I look in the mirror, what do I see? I see my reflection, right? I'm the exact same person, right? I haven't moved, I haven't done anything, my face doesn't look any different, okay? So if you do that, you get a equals a, or 4 equals 4, or something like that. Am I making sense? It seems like a silly one, but we need it, okay? Symmetric property of equality. If a equals b, then b equals a. This is where a lot of times I'll say like x equals 2, and then you guys are like, I have 2 equals x. Is that the same? We know it's the same, right? Because of the symmetric property of equality. The way I think of it is switch sides, symmetric switch sides, okay? Transitive property of equality is a little bit harder to understand. It says if a equals b and b equals c, then a equals c. What that means is if the first thing equals the second thing and the second thing equals the third thing, then the first equals the third. For example, if I say, I don't know, like 2 plus 2, what's 2 plus 2 equal? 4, obviously, right? So if I say 2 plus 2 equals 4, and 4 equals, I'm going to say 2 times 2, right? Isn't 2 plus 2 the first thing the same as 2 times 2 the last thing? That's what it's saying. So if you have two things equal to the same thing, if they're both equal to 4 or whatever, then they're equal to each other. That's the transitive property of equality. Pretty much anytime you see 3 things, it's probably transitive property of equality. Okay? So if the first thing equals the second thing and the second thing equals the third thing, then the first thing equals the third thing. All right. Substitution property of equality. Again, they make it look really, really fancy. If I wasn't here tomorrow or Monday, what would my replacement be called? Substitute, right? So anytime, let's go back to Algebra 1 again. If I get x equals 2 and I plug it back in, isn't that called substitution? Isn't that a fancy way of saying when you replace something, substitution? So they're saying if a equals b, then a may be replaced by b in any equation or expression. They're equal, so you can replace them, right? Distributive property. Everybody remembers this one every year. Everybody does great with this one. A parentheses b plus c equals ab plus ac. A lot of you guys probably still do that. Totally fine. That's distributive property. Okay? Additive inverse. Again, these look weird, but they're very easy. If I asked you what the opposite of 2 is, what would you tell me? What's the opposite of 2? Negative 2. Its additive inverse is negative 2, because if you look, 2 plus negative 2 is 0, right? If I ask you the multiplicative inverse of 2, inverse means invert, right? So what's the flip of 2 over 1? 1 over 2, right? So inverse means literally invert them, right? So over here, this is kind of scary looking. I don't have to explain that to you, but it's formal and proper. So if I had 2 over 1, you multiply by 1 over 2, and you get a 1. It's just a property. There's nothing for you guys to like think about here. They're just names, okay? Additive identity, when I think about identity, I think like if you break up with a boyfriend or girlfriend or whatever, you're like, I got my identity back, like I got myself back, right? So what do I have to add to 2 to get 2 back? What do I have to add to 2 to get 2? 0, very good, yeah. So if I take 2 plus 0, or any number plus 0, I get that number back. That's identity, okay? Multiplicative identity, same concept. If I'm 2, what do I multiply myself by? What do I multiply 2 by to get 2 back? 1. Any number times 1 gives you that number back. A bunch of properties, they're just names. Okay? So next page. A formal proof or 2-column proof. In this class, we typically do 2-column proofs. There's other kinds, but they're a little bit harder, so we just do the easiest possible. So they're going to give you what's called a given. It's kind of like the question, okay? And then they're going to give you a proof statement. It's the answer. It's not a trick. They give you the answer, and you just kind of have to fill it in the middle, okay? So this is how they usually look. We do 2 columns. That's why it's called a 2-column proof. We call the left side statements, and we call the right side reasons. And then you number both of them, 1, 1, 2, 2. Okay? Before we can even do a proof, we have to make sure we understand the properties. So let's just practice with a couple. It says, state the property that justifies each statement. So this first one says, if 5 is equal to x, then x is also equal to 5. So we have to go through that list on your front page and see which one it looks like, right? So what even happened from before the comma to after the comma? What happened? Exactly, they switched sides. Which property is switch sides? Switch sides, switch sides. Starts with an S. That's how I remember. Symmetric. Do you guys see the symmetric property where they literally just switched sides? Okay? So this is symmetric property of equality. Even I shorten them. So if you aren't going to know that SYMM means symmetric, then don't shorten it, right? You could write the whole word, okay? But SYMM is symmetric for me, okay? So symmetric property of equality. On this next one, if AB equals 1/2 CD, then 2AB equals CD, okay? So what I'm asking is, from before the comma to after the comma, kind of like what happens? Just in the tray for me. Thank you so much. So from here to here, let's maybe ignore this part here. Let's pretend this said like 4 equals 1/2 x. That's kind of what it looks like. What would you do to both sides to get the x alone? Multiply by 2 over 1 or divide by 1/2. Like either way is fine. You guys get that, right? So if I were to multiply this side by 2, I'd have to multiply that side by 2, right? But what happened was I ended up with a 1 CD, which is what they have, and a 2 AB, which is what they have. Does that make sense? I multiplied by the same number on both sides, so I would call that multiplication property of equality. All right? If you, in your head, thought, well, I would have divided by 1/2, that's not wrong either. You would have called it division property of equality. Do you guys get either way is fine? Okay? I'm going to do multiplication, though. Multiplication property of equality. Okay? This last one, if AB equals BC and BC equals CD, then AB equals CD. So I'm just going to tell you, it's probably transitive because look, if 1 to 2, 2 to 3, 1 to 3. Okay? But I'll slow it down though. But when it's 3 pieces like that, it's probably transitive. So if the first thing equals the second thing, and then I repeat the second thing equals a new third thing, then you cut out the middleman. Okay, and the first thing is equal to the third thing. That's transitive. Okay? Transitive property of equality. Everybody kind of okay? All right? So let's do a couple. This first question, it says given 6 parentheses x minus 4 equals 42, prove x is 11. It's not a trick. The answer is 11. If you don't get x equals 11, you messed up. It's never a trick. Okay? So, what we're going to do is step 1 is always the given every single time. Every single time you write the given exactly how they gave it to you. Don't do any math yet. Don't simplify or anything. You literally just copy it down. Okay? So, 6 parentheses x minus 4 equals 42. So, on a test or a quiz, if that's the only thing you write down and you have it right, you get a point. Okay, try to get more than that, but I want you to know that that's how easy that step is, every time, okay? From here, eventually, like our very last step, is going to be x equals 11, and we know we're done and we stop, all right? So I'm kind of just filling in the middle, okay? Definitely don't work ahead of me today, because I know algebraically you guys know how to do this, but for the proof part, you kind of don't, so don't get too far, okay? So number 2, what would we do to solve this? Very good. We would distribute. So we're going to go ahead and distribute. So on proofs, you don't really show the work. What I mean is, like, I'm not going to draw the arrows. Obviously, if you guys draw those arrows, I'm not going to mark it wrong. I'm just showing you the super fancy formal way of doing it, okay? So what would we get if we multiplied 6 times x? 6x, and then minus 24 still equals 42. Good. And you guys just told me what we did. What did we do just now? Distribute? So it's a distributive property, right? Distributive property of equality. Okay? What would we do next in Algebra 1? We would add 24 to both sides. So pause. In a proof, we don't put plus 24 plus 24. Okay? I know that seems weird, but it'll make sense why later. So what I'm going to do is I'm going to make it a whole new step. I'm still going to have 6x minus 24. That's still there. But I'm going to add it this way instead of vertically. So I'm adding it horizontally. I know you would think that doesn't matter, but here it does. Because every new step has to have a new reason. If I just shoved plus 24 kind of randomly in there, like we did in Algebra 1, we can't really say a reason for that. Do you guys see what I'm saying? Okay, so just do it this way instead of this way. That's what I'm saying. So what did I do to both sides? What did I put on both sides? Say it again. We added the exact same thing to both sides, so wouldn't that be addition property? Right? So addition property of equality. Okay? So now we say what we get. We actually do the adding. Alright? So on this left side, what do I end up with? 6x, right? Plus 0, but we don't write that. That's weird. Okay? And then what's 42 plus 24? 66. So pause here. I replaced 42 plus 24 with 66. What's that called? I replaced this with that. Substitution. Don't just put sub because we have subtraction as well. At least give me the ST like I did, okay? Substitution property of equality. Are you guys following me? Am I going too fast? Okay, good. A lot of people are tempted to call this addition because they did adding. Do you see what I'm saying? But actually, property-wise, whenever you do the math, it's called substitution. The addition property was showing the adding on both sides, not actually doing the adding. Okay? So now in Algebra 1, what would you have done? You would divide by 6. Don't just shove an over 6 here because I can't really show that step. Okay? So you basically write it again. 6x equals 66. You can do it here. Do you see what I'm saying? Or you can do it long ways. You don't have to do both. I'm okay with this. But you could do like this instead. I accept either way on this, all right? But don't just shove over 6's on step 4 because it has its own property. Step 5 is a whole new step. Do you guys see what I'm saying? Okay. So I'm fine with you keeping it this way, right? And what did we do to both sides? We divided, right? So division property of equality. Okay? What do we get? X equals 11. Because I replaced this with a 1x and I replaced this with an 11. I did the math. So anytime you do the math, we call it substitution. Good. Again, don't just call it sub because that could be subtraction, right? So here's where we go to the proof statement. Do I have exactly what they have, exactly how they have it? Yes. What I'm saying is, let's pretend for a second they had 11 equals x instead. Even though we know that's the same, I'd have to add step 7, switch sides, and call it symmetric. Do you see what I'm saying? It has to be exactly what they have. Okay? I need to hear you say, I can do this algebra. I need to hear you say, I'm okay at the properties. Okay? So you may not be perfect with the property side, but at least you're good with the left side, right? The algebra is easy. Okay? Let's try another one. Step 1, every time it's not a trick, you write the given exactly how they gave it to you. Don't do any math. Just write it down. Okay? So 5x minus 3 equals 12x plus 6. And what's that called? Given. Yeah, not a trick question. It's called given because it is given. Okay? Step 2. On this question, Just set it in the tray for me if you're done. Okay, thanks. On this question, we have 4 options to start this problem, right? I could subtract 5x from both sides. I could add 3 to both sides. I could subtract 12x from both sides. I could subtract 6 from both sides. You guys get you have 4 choices. You could do whatever you want. You may not do what your friend does, and that's fine. But since we're doing it together in the notes, let's all do it the same, okay? Whenever I solve for something, I work with the variable, the letter first. I keep it positive. That's how I prefer to do it. So for me, I would subtract the 5x from both sides. But I have to write that long ways, right? So I'm going to rewrite the 5x minus 3. That's still true. And then I'm going to subtract the 5x at the end, okay? And then the 12x plus 6 is still there, and the minus 5x at the end. Remember, we don't do it vertically because we can't really show a new statement for that, all right? What did I do to both sides? I what now? Yeah, I subtracted, right? So again, don't just give me sub, at least give me the TR, because sub could mean substitution, right? So subtraction, property of equality. At this point, they're all property of equality. If you don't want to write that part anymore, you don't have to. I just wanted to show you the super formal way, okay? So subtraction is fine. Eventually, we have like property of congruence and stuff, but as long as you have subtraction, I count it fine, okay? So from there, we actually do that math. So what do I end up with on the left side? The negative 3 is left over, right? And on the right side, when you combine like terms, what do you get? Yeah, the 12x minus the 5x is 7x and still plus 6. Everybody comfortable with that algebraically? Okay. So I actually did math. What's that called? Substitution. Very good. Substitution. Again, if you want to keep writing property of equality, technically we should, but I'm not that concerned. Okay? What do I have to do next? What do I have to do next? Subtract the 6, right? Don't just shove it underneath. We don't do that on these. So negative 3 minus 6 equals 7x plus 6 minus 6. Okay? What did I do to both sides? I subtracted, so it's subtraction, right? What do I get? What's negative 3 minus 6? Negative 9, and then these cancel out, and I'm left with a 7x. So I did the math, so what's that called? Substitution. Very good. What would I do now? To get x alone, what's in the way of x? The 7's in the way. They're multiplying, so to undo it, we divide. Oh my goodness. I've had so many spams today. Sorry, guys. So I divide by 7 on both sides. So negative 9 over 7 equals 7x over 7. I know how tempting it is to do it the Algebra 1 way, which is not wrong at all, by the way. But for geometry proofs, we have to show like the whole thing. Okay? So what did I do to both sides? Divided. So it's the division property of equality. Okay? What do I get? Negative 9 over 7 equals x. That's called substitution, because I did do the math. Even though I didn't have to do much, I did do it, right? So is that exactly what the proof statement says, exactly how it says it? No. It's super close, right? So I need to switch sides, which is called symmetric property of equality. Switch sides is symmetric. Do you guys get that? I know this seems like it's the same, but for a proof it's not. You have to give that one last step. Okay? So my given, my proof statement, I'm done. It's never a trick. If you don't get negative 9 over 7, you messed up somewhere. Okay? Does anybody have a question? All right. Let's do another one. So this next one is the exact same concept as what we just did, so I'm going to skip that one. If we have time at the end and you guys want me to come back to it, I can, but do you guys see that you have 4 choices just like that other one? So I don't think we need to do that again, okay? This one, we could go ahead and do, or is there anything I want to add? I say let's just skip to the last one. I think, because honestly, the last one, do you guys see how it's the exact same but a little bit harder, an extra step? So let's just do the last one. Again, if you guys feel you need extra examples, please let me know. But I think this third one should probably be good. It's okay. Thank you. All right, so step 1 is always the given. So 2 parentheses 5 minus 3x minus 4 parentheses x plus 7 equals 92. What's it called? Given. Good job. Everybody should get that one right? Excuse me. What am I going to do on step 2 here? I'm going to distribute. So what's the statement going to be, or excuse me, what's the reason going to be? You just said distribute, so it's going to be distribute, right? So we'll do our distributive property. What is 2 times 5? 10, and then what? Yes, negative 6x, right? Be careful here. Negative 4 times positive x is negative 4x, and negative 4 times positive 7, negative 28. Good. Still equal to 92. I just used the distributive property, so it's the distributive property, right? Distributive property of equality. Okay? Even in algebra, we would combine like terms before moving stuff around, right? So on this, I see a negative 6x minus 4x. So what is negative 6x minus 4x? Negative 10x. I see a 10 minus 28. So what would I call that? Negative 18, and I'm still equal to 92. Do you guys get that? You could have obviously had negative 18 minus 10x. That's the same too. Either way, it doesn't matter. So I just did math. So what's that called? Excellent. Substitution. Good. Okay. What do I have to do next? Add 18. So I'm going to rewrite it. Negative 10x minus 18. I'm going to add the 18 now. Equals 92 plus the 18. Okay. What did we do to both sides? Added. So addition property of equality. Right? What do we get? Negative 10x equals... what's 92 plus 18? 110. Good. Take your time, okay? I just did math, so what's that called? Substitution again, right? Eventually, you guys can put all this in one step. You don't have to do addition, substitution, subtraction, substitution, but for the first day, we do, okay? So now what do I do to both sides? So I rewrite it. Negative 10x equals 110, and you can put over negative 10 on each side like this. That's fine, okay? What did I do? Division, right? And what do I get? Grab your calculator. What do we get? Negative 110, or excuse me, positive 110 divided by negative 10. Obviously, it's a negative, right? A negative 11. So we did math, substitution. Is this exactly what the proof statement has, exactly how it has it? Yes. So we're good. Okay? I'm going to end the video, but if you guys needed more examples, I'm happy to do those in just a second. Okay?